Good morning one and all. Till now we have discussed about the what is meant by chromatography, that means about the definition of the chromatography and about the history of chromatography and also about the different types of chromatographies based on the shape, principle and all its activities. Now we are going to those types of chromatographies. Among those types of chromatographies, first of all we are discussing about the column chromatography. So what is meant by column chromatography? It is also a chromatographic technique, but here we are using the column as a chromatographic bed. That's why its name came as column chromatography. And coming to it here, this column chromatography is also divided into two types. Those are column adsorption chromatography and column partition chromatography. Column adsorption chromatography means here the main principle is adsorption, whereas column chromatography, partition chromatography means partition is the main principle. And in column adsorption chromatography, the stationary phase is solid and the mobile phase is liquid. Whereas in column partition chromatography, the stationary phase is liquid as well as the mobile phase is liquid. These are the two differences between this column adsorption chromatography and column partition chromatography. Coming to the column adsorption chromatography or adsorption column chromatography, the main principle behind it is, already I have discussed with you in the name itself, it is there that it is a column adsorption chromatography. That means the main principle is adsorption. That means whenever we are introducing the sample or mixture of compounds into the column, based on the adsorption affinity, that means based on its binding interaction or its affinity towards the stationary phase and mobile phase, the separation will happen. That means if the in the sample mixture so many components will be there, those components, some components will have affinity with the stationary phase, some components will have affinity with the mobile phase. The components which are having more affinity with the stationary phase, they will attain with the stationary phase for some time and elute later. The components which are having more affinity with the mobile phase, they will move fast and elute faster than the components which are having more affinity with the stationary phase. This is the main principle which is happening in the adsorption column chromatography. That means that separation will be happen based on the affinity of the components with the stationary phase and the mobile phase. And based on this principle only, they have given one formula, that means the rate of movement, that means whatever components which are going to be separated, based on their movement, the formula is given, that is how the movement takes place is defined as R. R is equal to rate of movement of the component, that means the sample which is separated, divided by the rate of movement of the mobile phase. Already you know mobile phase means it is a movable thing, it will always move. So we are comparing the movement of the sample with the mobile phase. That is one formula. Whenever we are using the partition column chromatography, that means in which the stationary phase and mobile phase will be liquid, at that time the formula will be changed, that is the moment R or the rate of movement is equal to AM by AM alpha into AS. AM by AM plus alpha into AS. AM and AS means those are nothing but area average cross section of mobile phase, and AS means average cross section of stationary phase. What is meant by this average cross section? Means the area or the how much capacity of that sample is attained or involved in the stationary phase, and the how much area occupied by that sample in the mobile phase is nothing but the area of cross section of that sample in the stationary phase and area of cross section of that sample in the mobile phase. And alpha means concentration of the sample in stationary phase and the concentration of the sample in the mobile phase. This formula we will use whenever we are using the liquid mobile phase and stationary phase, and the above sample we will use whenever we are doing with the adsorption column chromatography. These are all the things behind the principle. And coming to the practical requirements, before going to do the experiment, we have to get all the things to do the experiment. What are those practical requirements? First of all, stationary phase we have to need, mobile phase. After getting all those two, we have to start with the column. That means we have to get the column, and then we have to prepare that column, and then we have to introduce the sample, and the development will take place. That developmented sample we have to detect, and then finally we have to separate that component. These are the sequence wise steps which are happening in the experimental part. First of all, we will go within a line. First one is stationary phase. You already know the other name for stationary phase is adsorbent. So what are the requirements for a substance or for a chemical compound to act as a stationary phase? What are its requirements? Ideal requirements. First of all, the stationary phase should have the capability to adsorb the analyte on it. Understood? And second one is, whatever the stationary phase we are using, the particles which are present in that stationary phase should be in uniform size. That means there will be no irregularity in the shape. And mostly the size, particle size of that stationary phase in between 60 to 200 microns is very perfect and very efficient to be used as a stationary phase. And one more thing is, the stationary phase should be mechanically stable and should not react with the sample compounds or mobile phase or anything. It should be inert. Its main thing is it should act as a adsorbent. And one more thing is, it should be insoluble in the solvents or mobile phases used. That means not only it should not react with the sample, the stationary phase whatever we are using, it should also be insoluble or unreact with the solvents or mobile phases we are using. And one more thing is, it should be colorless. Why? If it is also colorless, colorful means, and also the sample which we are going to separate also color means, if both are same color means there will be no proper identification of the separation. Mostly the colorless stationary phases, colorless mobile phases will be beneficial for good separation of the components. These are the ideal characters which a particular compound should possess to act as a stationary phase. And coming to the next thing, what are the different types of stationary phases which we can use as a stationary phase in column adsorption chromatography? Those are weak stationary phases. That means they will be act as a stationary phases, but they have weak adsorption capabilities. Those are sucrose, starch, inulin, talc. And coming to the medium, that means they will act as an adsorbents but having medium capability of adsorption. Those are calcium carbonate, calcium phosphate, magnesium carbonate, magnesium oxide, like that. And coming to the strong adsorbents or strong stationary phases, that means if you are using those stationary phases, they can act as a stationary phase or adsorbent very efficiently. Those are activated magnesium silicate, activated charcoal, activated alumina, activated magnesia, all those things. These are the different types of stationary phases. Coming to the whatever stationary phase we are using, for example, already you have discussed the examples of stationary phases. Among those stationary phases, which one we are using? Whenever we have used a particular stationary phase, what are its requirements? That means how the stationary phase should act. What are its things to act as a stationary phase? First of all, removal of impurities. Whenever we are using a stationary phase, how much amount of stationary phase we have to use depends upon these characteristics. For example, if you are identifying different types of impurities present in a chemical compound, if there are very less amount of impurities, less amount of stationary phase is sufficient to remove those impurities. If so many impurities are there in that compound, more amount of stationary phase is used. And coming to the number of components to be separated, for example, you are taking one mixture, complex mixture, in that 100 components are there to separate. That means there are so many components to separate. Number of components to be separated is increasing means obviously the amount of stationary phase or adsorbent we are using, it should be more. That means it should be strong. If there are very less components to be get separated, weak adsorbent is necessary to separate those less amount of components. Then next one is affinity differences between different components. It is very, very important. For example, whenever the components which we are going to separate are having similar affinities, that means in that mixture there are 10 components. Among those 10 components, 6 components are very less affinity. That means very closure. Then very strong adsorbent is there because they are very lightly attracted. Affinity differences are also very less. They are seen to be same molecular weight, same structure. Then those type of compounds, for those type of compounds to separate, very strong adsorbent is needed. For example, if the component is having the samples or components in that mixture are having very larger affinity differences, then we can identify easily. That means weak adsorbent is enough to separate those very large affinity differences components. It is very, very important point, listen. And then next one is length of column used. Whenever we are using very short column, you have to use very strong adsorbent. Why? Because the length is very small and also very few amount of stationary phase only we can accumulate. And if you want to separate so many components, means whatever the amount of stationary, very less amount of stationary phase only we are using, but that less amount of stationary phase also it should efficiently separate the components. That's why very strong adsorbent is used. Whenever we are using very lengthy column, even though if it is lengthy also, that means it is lengthy, that's why we have to use very weak adsorbent. That means weak adsorbent is also enough to separate the components, because the length of the column is more, there will be more place for the separation of the components. So weak adsorbent also can efficiently separate the components. And coming to the quantity of adsorbent you are using, because here the quantity is very very important. Why? Because whatever the sample you are separating, to that weight you have to use 20 to 30 times more weight of the adsorbent. For example, if you want to separate 1 gram of paracetamol component mixture, what are the components which are present in the paracetamol you want to separate? If you are using 1 gram of paracetamol, you have to use 20 to 30 grams of adsorbent. That means 20 to 30 times more of the weight of the sample you have to use the stationary phase. These are the things you have to consider whenever you are using the stationary phase. And coming to the next part, mobile phase. You have completed the stationary phase. What are its ideal requirements? What are the types? And what type of adsorbent you have to use whenever the steps are changing. And coming to the mobile phase, it is very very important. Already I told you, whatever mobile phase we are using, it should act as in a 3 ways. First of all, it should act as a solvent. That means because it acts as a mobile phase, it will move the sample or it will elute the sample. That's why it should be compatible or solubilize the solvent. That's why it acts as a solvent. And not only that it should act as a solvent, it should act as a developer or joiner of separation. That means it should act as a developing agent for the separation of the component. First of all, it should act as a solvent, and also it should act as a developing agent. That means the mobile phase should separate the component by making it elute along with it. That means it was making elution of the component. That's why it acts as a developing agent. And also mainly it should act as a component for separation of the pure component from the mobile phase. That means already I told you, the sample will elute along with the mobile phase. That means it will make the sample to elute along with. Finally, that eluted compound should be get separated from the mobile phase. So the 3 functions of the mobile phase are: it should act as a solvent, it should act as a developing agent, and also it should act as a separator of the pure component. Understood? And coming to the next part, that means different mobile phases. Already we have seen the different types of stationary phases. Like that, what are different types of mobile phases we can use? Or petroleum ether, carbon tetrachloride, benzene, toluene, acetylene, different types of alcohols. Whatever the mobile phases you are using, you have to must and shouldly think about the polarity nature or polar nature of the mobile phases. Whether it is highly polar or mid-polar or non-polar, you have to consider. Based on the compound you are separating, you have to choose the mobile phase. Based on the component which one you are separating, based on the molarity of that component, you have to choose or select the mobile phase. That means polarity, non-polarity natures of the mobile phases and sample should be compatible. Understood? And coming to the next part, column characteristics. That means we have taken the stationary phase, you have to take in the mobile phase, and you have to set up the column characteristics. That means already I have shown you in the figure. Mostly we will take which material made column, means mostly you can take the glass, because that too best quality glass like borosilicate glasses you can take, because these are these things will got not affected by the solvents. You know already, glass, inert glass which is not affected by the solvents, that glass is preferable. And also the length and diameter ratio of the column. See, this is the length of the column and this is the diameter. Whatever column we are taking, the major efficient ratios of length and diameter are mostly you can take 10 to 15 centimeters length column and 1 centimeter diameter is the preferable one. If you want more efficient separation, 100:1. That means for the complex mixtures, if you want to separate more number of components, 100:1. That means 100 centimeters of length of column is to 1 centimeter diameter of the column is more preferable for more efficient separation of complex mixtures. And coming to the next thing, preparation of the column. That means already first of all you have seen what type of column you have to take. So after taking that glass column with the correct dimensions of length and diameter, you have to prepare that column. That means first whenever you have taken the column, so how you have to put all the things inside the column is nothing but the preparation of column. First you have to take the column. See, first you have to take the column, and then first you have to keep the glass wool at the bottom of the column. Why you have to keep the glass wool? You can keep the glass wool or cotton wool or asbestosis pad. Why? What is the necessary? Why we have to keep the glass wool or cotton wool or asbestosis pad at the bottom means it acts as an insulator for unnecessary moving of the stationary phase or adsorbent, and also for the uniform packing of the silica gel, that is stationary phase or adsorbent. You have to know must and shouldly why we are using this glass wool or cotton wool. It acts as an insulator to remove the unnecessary movement of the silica gel, that is stationary phase, above, and also for the uniform packing of the silica gel. And the next part is, after keeping the glass wool at the bottom, you have to add the stationary phase. Mostly commonly used stationary phase is silica gel. It will be in a powdery structure like salt. After keeping the glass wool, you have to add the stationary phase. After filling with the stationary phase, again above here you have to keep one paper disc. Why? For the uniform distribution of the stationary phase. That means to keep it in a one level, you have to keep one paper disc, and then you have to add the mobile phase and the sample which we are going to separate. Understood? The stepwise, first you have to keep the glass wool or cotton wool, and then you have to add the stationary phase, silica, and then you have to add the mobile phase with the solvents. This is the preparation of the column. So here in the theory part also same thing. First you have to keep the glass wool or cotton wool or asbestosis, and then you have to pack with the stationary phase. After that you have to keep the paper disc, and then you have to introduce the sample along with the mobile phase. This filling, that is called as filling. This filling is of two types. One is dry packing or dry filling, and another one is wet packing or wet filling. Why? In the name itself it was telling that if you are adding the silica, whatever you are adding the silica, if you are adding in a dry form, dry silica powder if you are adding, then it is called as dry packing. And if you are taking the silica powder in the beaker, and then to that if you are adding the solvent or mobile phase, and then you are adding in the column, then it is called as wet filling. That means you are making the silica powder, dry powder into wet form in the wet filling, and in dry filling means dry powder only we are adding. But among those two, dry filling and wet filling is the best method. Why? In the dry filling you are adding the dry silica powder, but if you are in the dry filling, what are the disadvantages means that is the dry powder, so separation will not be efficient. There will be erasing of some air bubbles, there will be no good separation of color bands. Why? That is the dry powder, there will be no efficient separation. But in wet filling you are already mixing that silica powder with the solvent, already it is little bit wet. Whenever we are adding the solvent also, which is in the liquidy form, there will be nice separation, there will be no formation of air bubbles or crackings, or there will be no uneven distribution of the sample in the stationary phase. That's why among these two, wet filling is the most advanced and useful one than dry filling. So this is the dry filling. That means we will fill the stationary phase in the dry form, whereas in the wet filling we will mix the stationary phase before entering it, keeping in the column with the solvent or mobile phase, and then we will fill in the column. And among these two, wet filling is the more efficient one. After filling, everything you got separated, setup, that means taken the column, added everything, and then you have to left the setup for some time. Why? You have to leave, you should not disturb it. Why means to make all the sample to get into the stationary phase, and it should get started separation or elution. That is called as development or elution technique. There are two types of elution techniques: isocratic elution, gradient elution. Iso means same. Whenever if you are using same amount of mobile phase throughout the experiment, from the starting point of experiment till the ending point of experiment, if you are using same composition of mobile phase with same concentration with same amount, then it is called as isocratic elution. Whereas gradient elution means if you are changing the composition of the mobile phase, first if you are using 50 ml of ethanol plus 50 ml of water, and then after 10 minutes if you change the 40 composition as 40 ml of ethanol plus 60 ml of water, and then after 10 minutes if you change it as 30 ml of ethanol plus 70 ml of water, that means you are changing the composition and you are adding, then it is called as gradient. That means gradient means increasing level of polarity nature of the mobile phase. If you are adding like that by changing the compositions, then it is called as gradient. Whereas in isocratic, same mobile phase, same amount, same concentration. Whereas gradient, we will increase the, or we will change the composition in the increasing polarity nature of the mobile phase. It is very, very important. Best example for isocratic is petroleum ether and benzene in 1:1 ratio throughout the experiment. Whereas in isocratic, initially benzene, and then chloroform, and then ethyl acetate, and then again chloroform. That means you are changing the mobile phase components by one after some time. That is called as gradient elution. These are the two types of elutions. Coming to the detections, after all these things, mobile phase, stationary phase, column, everything you kept and kept aside for elution. After the elution takes place, that means after the components are separated very efficiently, you have to detect. Based, for example, if the component is color, it will give color bands. One component will be in one color, you can see in the column, one component in one color, one component in one color. That means if it is the colorful compound, you can visually see the separation nicely in the form of color compounds. But if the component is colorless, and it is separated, but if it is colorless, you can't see which is separated at which part, which component is separated at which part. So for those colorless compounds, how to detect? We can detect by other methods. Those methods are by measuring under UV visible spectrometer. That means that compound we will take and we will send the UV light, how much UV or visible light the sample got absorbed. Based on that absorption, you will detect what is that compound. And another method is based on the fluorescence, how much fluorescence light is emitted by the compound. By detecting that fluorescence, you can detect which compound it is. And also the other methods are by using the flame ionization detector. We will send one flame under that sample, how much sample got burned, and by burning under the flame, how many ions are formed. Based on that different types of ions, you can detect the sample by using flame ionization detector. And coming to refractive index detector, you already know refractive index detector means whenever we are passing light through that sample, how much light is got refracted or diffracted or scattered. Based on that scattering, you will detect the sample. And other things are by doing the evaporation and so also you can detect. All these detection techniques are used whenever the sample is colorless. If it is color, you can visually only you can detect different types of color bands. These are all regarding the detection. Coming to the final thing, recovery of the components. That means already you detected, you seen how you have to collect. Recovery means how you have to collect. For example, if it is color bands will be formed in the column. That color bands you have to collect and cut, because those color bands will be formed in the silica gel powder. That means already silica gel will be there along with that sample. So you have to collect that color bands. For example, orange colored band will be formed in the column, green colored band, yellow colored band, all those silica colored bands you have to collect and cut. You have to cut at each part of the color. You have to cut those sectors and are bands of different colors, and you have to filter it to remove the silica gel and to get the pure amount of component. That is called as recovery. In so many cases, they will use some other processes, like after separation of 10 to 15 minutes they will collect one color band. They will wait for 10 to 20 minutes and then one more color band will form. Then they will collect that color band. After 10 to 20 minutes they will wait, and after that they will collect another color band, and they will take all those color bands and they will cut it, and then they will filter it to remove the silica, and then they will get the pure sample compound. These are the things which are happening in the column chromatography. And the last thing is factors affecting column efficiency. What are the different factors affecting column efficiency? I already told you. First one is dimensions. I already told you 100:1. That means length 100 centimeters and diameter 1 centimeter is very good efficient column. If you are using these measurements, you can get better column efficiency. And the next one is particle size. If you are using very less particle size, there will be column will be worked very efficiently, because big particle size means there will be no good separation. And the next one is nature of the solvent. Already I told you, the solvent, if it is very less viscous, then it will be more efficient. If it is high viscous, it can't separate. You already know, highly viscous means it will not flow easily. So less viscous solvent means more separation. Temperature also, if there is more temperature, the separation will be more. Pressure, if there is more pressure, the column will separate the things very efficiently. And the last one is applications. So finally you have seen all those things. So this column adsorption chromatography you can use for so many separations, like separation of glycosides, amino acids, proteins, plant extracts, and also separation of impurities. Best example is it can be used for separation of metabolites. For example, in the urine, what are the steroids if they are present? How to separate those steroids and cortisols in the urine sample? You can use this column chromatography. And also for the separation of different types of drugs, and also for the separation of enantiomers, diastereomers, that means levorotatory, dextrorotatory, all those things, tautomers, racemic mixtures also you can separate by using this column chromatography. And advantages means same things you can write. You can separate any type of sample. You can use widely, and it is planting is also, experimentation part is also very easy. Last thing is disadvantages. It is time consuming method, and also you need more amount of solvent and more amount of silica gel, and automation makes the technique more complicated. That means automatically you can't use. Person is very essential. Okay, these are the things which are happening in the column chromatography. Thank you.